introduction. All right, so thanks for bearing with me here and not going to the Java E8 talk. One thing I can offer you up right now is this is stuff you can use right now and probably not a few years ahead and maybe never. All right, so I hope you picked the right talk. As you said, my name is Nitschinger. I work for Couchbase, and this talk will be about RxJava and reactive data access. So all the RxJava pieces, of course, you can use without Couchbase, but I picked all the examples with Couchbase so you can relate to it, and because we natively implement all the observable stuff and RxJava stuff that you'll see, it's much easier to basically get started with it. And maybe some of the topics are, okay, let me start differently. Who has used RxJava or any asynchronous, reactive kind of APIs before? 3, 4, okay, great. So for the others, maybe it will be a rough ride up front, because if you have never seen very function-oriented programming, right, it is hard to get started, but once you're over that initial leap, and I encourage you to try it out at home later, once you're over the initial leap, it's awesome to use, and you don't want to go back at some point. So reactive, the term is again overloaded, but when I started using it 3 years ago, it wasn't cool. But at that time, we were migrating or rewriting our Java client for Couchbase, and we were facing some challenges. We wanted a completely asynchronous client, which is high performing and doesn't hog up any resources that you don't need. And while we developed the client, I found out that more and more of those use cases I had, we could bubble them up the stack and give it available to users because they were facing the exact same challenges. So what the whole reactive thing and whatever it is, right? If you're using Akka or any other library, the main piece of reactive is not tied to a library. But what it actually means is you have those new challenges, right? What you want is that under high load, you want to react to failure in a very deterministic way, right? Because in traditional applications, if you face very high load, or if you need to react to failure, it's very hard, and your programming model is not used to that. And we'll see a little later how both the APIs and the behavior of something like RxJava naturally leads you to more resilient applications, both under load and under failure, right? They provide primitives and semantics to deal with exactly those scenarios up front, and it's not an afterthought, which is very important if you're building such applications. And as it turned out, many companies, like 3 years ago, Netflix and so forth, they set out to build something like RxJava because they had these challenges and they couldn't find adequate solutions for their problems. And more people are now running into those scenarios, right? And this is why the whole reactive theme, it got so popular, and more libraries are adopting it. And under the hood, what's actually common for all those implementations is you have decoupled event-driven architectures, right? You're going away from lots of blocking pieces of code. Maybe under the hood there is some synchronization going on, but from a programming model point of view, you have a completely event-driven architecture. It's not pull-based, but it's push-based, and that makes it completely different when you are programming your applications. And as a result, right, if you do it right, if you get a complete asynchronous stack, that's the result, right? So you get optimal resource utilization, and then as a result, you get better, you can react better to load and other failure because you get more headroom, right? So, or in one meme, the latency is too damn high for most of people, and we need to find alternatives. So, to give you a quick overview of the reactive landscape right now, I'll be talking about RxJava 1, which is the current stable release, and it's not using an interface what is called reactive streams. So if you go to reactivestreams.org, which is basically a spec, an API spec, where reactive implementations try to conform to, so you can have interoperability between them. Libraries like RxJava 2, which is currently in the release candidate, or Milestone 2, something like that, or Reactive 3 from the Spring guys, or Akka streams from TypeSafe, they're already implementing the spec, and you can use them together. If you want to expose reactive streams from RxJava 1, there is a bridge which you can use from RxJava 1 to reactive streams, right? But 90% of the concepts that you'll see today, you can literally take them one-to-one with a little bit of syntactical differences and apply them to these other libraries, right? So don't worry. Now, before we dig into RxJava and reactive querying, I need to give a little bit of a detour on Couchbase, because who has heard about Couchbase? Wow, it's getting more and more people. That's pretty good, actually. Who has used Couchbase? One? Okay, great. More than a few years ago when I asked these kind of questions. So what Couchbase is a document-oriented database. We're coming from a very cache-oriented background, so it's a high-performance database. And recently we added a feature called Nickel. And Nickel is a SQL-ish query language, which if you're familiar with SQL, it will come very natural to you. But because we use JSON as a document type that you store and query, we added JSON stuff to SQL if you want, right? So it is a declarative query language like SQL, but we extend it for JSON support. That's basically all it is. And the Nickel name is actually, it's a play on the non-first normal form, because we store data in no normal form, right? All the data is denormalized, if you want, in Couchbase. So that's why we chose the name Nickel. And as you'll see later, if we have time for a demo, I'll show you the query UI, which is built in. But for now, you just think of it as it looks like SQL, right? And if it looks like SQL, then it's probably very similar. And what we also have full SDK support. So in Couchbase, we provide first-class language SDKs. So we have Java, .NET, Python, and so forth. And what I'll show you today is, of course, with Java. But if you are a Java and .NET shop, we take lots of care to make sure that the .NET APIs look like the Java ones, so you feel right at home. And our Nickel implementation is quite performant, because we have, even if it's a completely distributed system, right? We have very high performant index structures that allow you to, even in a distributed system, run those Nickel queries and get the results back very quickly. So just a quick idea so you can see how it looks like. On the left here we have a SQL statement. On the right there is a Nickel statement. And you'll probably ask yourself, it doesn't look much different. Well, that's the point, right? So here we do a select from with a group by, a having clause, and order by, right? And this thing here looks exactly the same. So you get all those semantics. The big difference is, of course, in SQL, you get some kind of table structure back. And the main difference in Nickel with Couchbase is your data is unstructured, right? Couchbase stores JSON documents, so unstructured data. So every row can look different. Here in this case, we just select the book at an average of a rating. But if you do like a select star, for example, every book can have different JSON objects. And the language also reflects that, because in JSON, you can have nested structure, right? You can have objects, inside array, inside objects, and so forth. And the language constructs allow you to do different kinds of things. For example, you can do joins with Nickel, right? So here we have an inner join, so we select name and year from the books. We do an inner join on a specific key, so that's basically our foreign key here. And in Couchbase, we can do the same. The main difference is that Couchbase gives you different access models. So one thing is Nickel, and the other one, which we'll also see later in the slides, is KV, right? So we're coming from a key value, cache-oriented background, so every document has a unique document ID, right, which we call the key. So in this case, what we say, we grab everything from awards, and we inner join it with the books on keys, and there our award basically references the book by its unique document ID, and then we load in the background we load the document and basically perform the join, right? So in the background we do key value fetches and make sure everything is properly fine in a distributed system, but you still get the join functionality here. So that's just two very quick examples. Of course, online you get all kinds of stuff on Nickel, just to give you a main idea how it looks like and some feeling. And the other thing I want to talk you through very quickly is how our Java client under the cover works, because this is very important if you want to build something like this, a completely asynchronous programming stack. An architecture like this that we're using, it has proven very resilient and efficient. So if you're using the Couchbase Java Client API, it looks very natural to you. So we have an asynchronous API, and then on top we have a synchronous one. And this is very important because you can always go from an asynchronous programming model to synchronous, but you can never do it the other way around, right? So the full client underneath is completely asynchronous. This is hidden to you, but if you're interested in, I think it's fine to look at. So on top of this Couchbase core layer here, you have all your application threads, right? They're talking to the SDK. But the first part that's very important is we are putting a ring buffer in here. So all the requests are not going into our I/O layer directly, but rather we send them into a ring buffer, which gives us nice back pressure semantics. The ring buffer is a fixed size. So if you're overloading the system, we can fail fast very quickly and tell you, wait a minute, you need to back off. And we also provide facilities to you as a user to do this back off in a very efficient way. Once the request lands into the ring buffer, we moved it off your application threads. So here is a dispatcher thread that is running inside the SDK, which is performing all kinds of location stuff, right? Because Couchbase is a distributed system, we need to find out which socket eventually we need to send the request to. And this is all figured out in here. So we select the right node, and then we select the service for each node, like Nickel or KV or full text search, right? We pick the right service. And then we pick the right endpoint, which is nothing more like a socket. It is an enhanced socket, basically. We're using Netty underneath for asynchronous I/O. If you're interested in asynchronous I/O, tomorrow I'm doing a talk on Netty, which is more low level, right? But today I'm not going to focus on that. So here we just write it into the channel, and then at some point we get a response from the server. We take the response, we put it into another ring buffer. This is also very important. I'll tell you in a second. And then we complete the observable, and the observable is our asynchronous object in RxJava, which we see a lot in a minute. But the important part here is to move it off of our I/O layer here and into another ring buffer, because this is happening on another thread. Because if we would complete the observable right away from our I/O layer, and you would block in an observable, for example, by accident or because you're doing some expansive computation, you would block and slow down I/O threads, which would in turn slow down the whole application. So by having very explicit boundaries with very explicit back pressure semantics, we have a very deterministic, basically, stack, but still a completely asynchronous fashion, right? And one other thing why we're using the ring buffer, and this is something that I'd like you to take away anyways, is that one thing that is called smart batching, and the term was coined by Martin Thompson. I recommend you to check out his blog posts and talks at various conferences. He's doing lots of high performance programming stuff. Is that you never want contention, right? That contention is bad, but it's especially bad in the I/O case. Because imagine we would allow your application threads to directly write into I/O layer. We would lose two things. The first thing we would lose is basically very good throughput performance, because if all those, let's say we have 3 application threads and they talk to I/O device without coordination, right? They would write, add contention here, because we would need some kind of queue, right? That has a multi-producer, single consumer thing. But down here, what we can't control is the TCP batching, right? Because they are basically writing and reading in an uncoordinated fashion, we need also to take the data and write it down to the I/O device in an uncoordinated fashion. Which means we would have suboptimal TCP batching, right? We would write smaller TCP requests and so forth, have more overhead. By using an explicit ring buffer between the application threads and our I/O device, we have a batching thread. We could, let's say our application layer is writing a little faster than our I/O device can handle, right? That's not unrealistic. In this case, what would happen? Let's say basically one request goes into the ring buffer, the batching thread picks it up and sends it to the I/O device. In the meantime, the other application threads already put 10 requests into the ring buffer. The next time the batching thread comes back to see what's in the ring buffer, it can take all of those requests at once and send it down to the I/O device, giving you implicit batching characteristics and better TCP performance and so forth, right? So removing contention and having more control over what you write down to the I/O device is very helpful for making sure the performance stays great, even if you're under higher load, which is one of the things we want to solve with those asynchronous architectures. All right. So that's a quick detour on asynchronous I/O and Nickel. Let's talk about RxJava. And I'll try to take it slow for starts. So what is RxJava? RxJava is a Java implementation of reactive extensions, which was originally done on .NET by Eric Meyer while he was still at Microsoft. But it kind of stalled at .NET, but the RxJava implementation really picked up steam 3 years ago. And what it eventually does is exactly what we want. So it is a library that allows us to compose asynchronous and event-driven programs. So the main abstraction with RxJava is an observable. What is an observable? Think of it as the asynchronous cousin of an iterable that you're all used to in Java, right? So imagine we have an API where we want to return a single result in a blocking fashion, while we would return type T, right? Obvious. If we want to do the same thing asynchronous, we would return something of type future T. So we would get a future back, and then once the future completes, we can extract the value out of it, right? And then, but what if we want to return more than one object, right? Or more than one T? Well, in the synchronous case, we would return an iterable, and in a pool-based fashion, we would go through the iterator and pick out the data as we need it. Now, in an asynchronous world, this is called an observable. And the opposite of pulling it out is actually pushing the data. So what you do is you register interest, what we call a subscription on an observable, and then once the observable gets the data, it pushes it to you, right? And that makes it possible to compose those kind of sequences, as we'll see in a bit. Now, taking it a step further, there are some kind of or very specific events that are raised in different contexts. So, as I said, the observables, you can think of them as the cousins and doers of iterables. And what they do is, and this is very subtle, but it's very important, they describe both latency and error side effects. Now, let's talk about how they expose those events first, and then I'll tell you why this is very important. So, imagine on an iterable, we want to get some data out of the iterable. Well, we call next and now iterate, and we get the object, right? If we find an error, then it throws an exception, or you throw an exception. If it completes, well, the iterator just returns, there is no more element in it, and you bail out. Now, it turns out on an observable, because we're all asynchronous, it's not that easy, right? You need to switch to an event-based model. So what you do is when you attach a subscriber to an observable, you can list on 3 events. The first one is on next, which will call it every time a new event basically comes into the observable. Like, for example, with Couchbase, you ask for a document, and once it returned, you get an on next event with your JSON document. Perfect. If something goes wrong, the on error event will be called with an exception what happened. And finally, once the observable completes, you get an uncompleted event. Now, how these events are basically raised, it very much depends on the circumstance. So you can have an empty observable where no on next will be raised, no on error, but just an uncompleted event, right? Imagine you're loading a document from the server, but it's not there. It will just return, yeah, okay, I'm done. I know there wasn't an error, but no document has been found, right? Or if an error happened. Now, why on earth does it also implicitly describe both latency and error side effects? Now, imagine an API where, well, let's say you're defining an interface of type T, where you pass an interface to your upstream component, and you say, okay, call this method, and I'll give you the data of type T. Okay, great. And in your first implementation, you just have a hash map backed by it, and you just return the data from there. That's fine, right? It takes a few microseconds, and you'll get the data out. But imagine what happens if your implementation grows too big and you decide, well, let's store the data in a database. Then your T doesn't describe the additional latency, right? You were basically going from microseconds now to milliseconds or even seconds to get the data out of it. But how do you represent this fact inside the API? You can't. But because we are moving to an asynchronous programming model, latency is implicit in the API defined, right? If you return a type of observable T instead of T, there is no specific time bound, right? The user just asks, return me the data once it's completed. It doesn't matter if it's 1 millisecond or 1 second, you get the data back, right? So you can evolve your API and hide the underlying implementation. And the same thing is for errors. Here we always have the on error as part of the observable contract. If you just return type T, well, you could start adding checked exceptions, right? Or you in your API docs, you define what exceptions could be thrown, but it's not really part of the contract. It's part of your Java doc, right? But here, because we have the error defined specifically in our observable, having latency and errors as a side effect is implicit in our observable description, which is very important if you're building those scalable APIs. All right, enough talk. Let's start look at some code, and I have lots of code for you to look at. So we have an observable. How can we consume it? So imagine here our bucket. Think of it as like a database now. So Couchbase bucket where our data is stored into, right? We call async to get our asynchronous API, and then we call get. And get does a key value fetch for a specific document. So here we ask for the document with the ID doc, right, inside our database. And then we subscribe to it, and this is very important. You need to subscribe to an observable, otherwise nothing happens, because it's completely reactive in a way, right? So if you just say bucket async get, semicolon, nothing will happen. You need to subscribe to it, and then every time you subscribe to it, the action will be performed. And in this case, we print out completed. When it's completed, we print out the stack trace on error. And I'll show you later how you can actually make use of that in a sane way, right? And here we print out what we found. So this is basically the very basic contract of observables. If you understand those 3 events, you're already good for that part. Now, yes?
Can I ask a question? The previous slide, could you be in the situation that on next gets called maybe 3 times and then you get an error?
Yes, this is totally fine and this is valid. So more formally, the contract of Rx's, what you basically call is you can call on next n times from 0 to n times, and then either an uncompleted or an on error follows. So it's basically the complete or the error terminates the observable sequence, right? Because once an error happens, no on next is allowed to be called anymore. That's very important, right? So you get 0 to n elements fed into it, right? And then either an error happens or your observable completes fine. That's the contract, basically. And also, the incomplete is optional. I know it's a little things, but imagine you have an observable that endlessly streams data, right? Let's say you're consuming a changes feed of Twitter or whatever, right? The observer just keeps sending you data all the time until you unsubscribe. So there is a way for you to unsubscribe. So if you subscribe, you get a subscription, and then you can unsubscribe if you don't want additional data. But there are operators which are provided by RxJava that make it more flexible. Now, they added two things recently in RxJava. So the observer was there always, but as I said, the observer allows you to stream 0 to n elements. And to make it more specific, because if you want to express an API maybe more in a more narrow fashion, what they added was like a single type, which behaves like an observable, but it only allows you to send 0 to 1 element, right? So if you have an API of single T, your consumer knows it will at maximum get 1 element and then an uncompleted event or an error, right? That makes it nicer to basically build an API. So for example, in the Java SDK with Couchbase, we have an observable of type document, but we know that if you do a get with one ID, there will only be one document. So either it finds the document or it doesn't. But the observable contract would, in theory, allow you to send more data to it, right? It's not harmful, but if you express it like this, it's more explicit what you're expecting from the asynchronous response. And then taking it one step further, there is something called a completable, and you can probably imagine already, all it does is it either completes or it completes successfully or it completes with an error. And this is helpful. For example, imagine you have an asynchronous API where you call a connect method. And all you want to know is, did it connect or did it connect with failure, basically? And then you can return a completed, and then you wait on it. And if it completes, then it's fine. And if it doesn't, you get an error and you can react to it. Right? So those are the three basic types. In this talk, we'll focus on the observable because the others are just special versions of it, right? Now, okay, that's fine. We know how to consume an observable. We subscribe to it, but how can we create one? And there are many ways to create one, and I just picked a couple so that you get a basic idea. So one way to create an observable is by using the just factory method. So you say observable.just, and for example, you give it an array of elements, and then it will and then it will take basically each element in the array, and then on the horizontal line here, this is called a marble diagram, and every element here on the axis basically describes one on next event. So let's say we are sending 6 integer values into observable, then on next will be called 6 times, and then we have an incomplete event, right? That's basically how it works, and then we can consume it. How does it look like in code? Well, we call observable.just ABC and our subscriber. And what we can also do, we don't always need to subscribe to all 3 events. We can also say, I'm just interested into on next events, right? And then this will print got A, got B, got C. And one important part here is this is not, so RxJava is not dictating to you any kind of threading structure. So this is running on your current thread. So if you execute this on main, it will run on main. And there are very specific ways how you can actually take an observable sequence and move it like to thread pool or so forth, right? If you have complex computations, you can move them to a thread pool to execute, and there are operators which execute specifically on other threads. Like interval. Interval is one of those. So you can have an observable that is created, and every interval that you specify, one event is emitted to your observable sequence. So for example, we can say observable.interval 2 seconds, and then every 2 seconds an event is emitted into observable, right? And then we can do something with it. Now, okay, we've created those, and as I said, there are many other ways to create observables available. Just check out the docs, but they will probably just be too much for this session. Now, the real fun with observables comes when you actually do something with them. You filter them, you transform them, you merge them together, you split them apart, right? That's where the real power comes from. So one of the ways you can change or modify the sequences is filter. You give it a predicate. Imagine we are emitting all those events here, but we are only interested in our circles, right? So we create a filter predicate where we say, let only the those circles pass through, and the other ones just drop them on the floor, right? So let's say we have observable just 1, 2, 3, 4, and then we create a filter. And by the way, I'm mixing and matching Java 8 syntax and Java 6 syntax, so you can use both, but so that you get a feeling that you can use both APIs. We say filter and drop everything on the floor where the predicate doesn't hold. So unsurprisingly, what our for each, which is a shorthand for subscribe with only the next events, it will only print 3 and 4 because 1 and 2 will drop on the floor, right? And we'll see how to make use of filter in a much better way soon. Another way to filter is with first and last. With first, you can say, oh, here is the sequence, but I'm only interested in the first one, right? Let the other ones, drop them on the floor, call onComplete, and because of the contract we talked about, onComplete is a terminal event. There are no next events allowed, otherwise it would be completely useless to have a complete event. So how can we use first? So on our Couchbase API, there is a method called getFromReplica. So you can have a master and you can have n replica copies. Normally when you do a get call, you get the data from master. But in some use cases, especially during failure, it might make sense for you to trade availability for consistency and ask, give me all the documents for this ID from all the replicas. Like you can have 0 to 3 replicas on the server side. In this case, what getFromReplica will return is an observable of type document, but it could return 0 to 3 documents, like from all the replicas, but you don't know, maybe you only have 1 replica or all the replicas are down, right? In our case, we're only interested in the first one. We say, please go ask all the replicas for the documents, but I'm just interested in one data, right, in the failure case. Just give me the first one. And here we call first. We take the first one that arrives and drop the other ones on the floor, right? And imagine we're exposing this as an API to the user. So we're exposing a observable of type document. The user doesn't know that we actually ask for many different documents and just grab the first one, right? That's the important part. Imagine you could start out with bucket async get and grab the document, and then 2 months later someone says, oh, we need to handle this failure case, and then you can have a fallback, which we'll show in a second, to get from replica, grab the documents and return it. But the user doesn't have to know that you actually, because it's all asynchronous, it's the same API that you fetch one document and in the failure case you go to the server and grab more, right? So that's the power of basically composing those asynchronous sequences. This is just a very simple example. Another one is map. Map is very straightforward. So you can give it a function and map all types of type T to type V, right? Very simple. So in our case, we can use map here. So we grab the document from the server, but the document has lots of different data associated when you load it. So it has a document ID, it has some metadata, there is expiration time, there is some mutation tokens, whatever, right? All kinds of metadata, but we are only interested in the content. So we call map and map the document from the document to the content. So basically the map function maps our observable of type JSON document to observable of type JSON object, and JSON object represents our content here where we can do our manipulations on, right? So the subscriber here, which could be somewhere in our system, doesn't know that we actually fetch the document. It just cares about the JSON object. And then in a test environment, you just mock it basically, and you say, I'm not going to the server. I just return observable.just JSON object, and you give it the mock data, right? And because from here on, it's all basically transparent in the background. It doesn't matter if it's coming from a database or from a local map. Now to something a little more complicated but very important, flat map. So what flat map does, it's like map, but it's going from a value T to type observable T. So, and then because we would end up, if we would say map, let's say we get a document ID, we fetch a document, and then based on the content of the document, we want to fetch another document, right? And this would actually mean observable of observable type T, which is not fun to use because your result of your observable would be not observable. And this is where flat map comes into place, right? It says, okay, I'm having this I'm taking this asynchronous sequences, and I'm flattening them down into one straight observable, right? So you take lots of different observables, and then you are flattening them onto one observable, and then your downstream consumer doesn't know it was actually like 6 different observables. They all will emit events on one observable. Any questions? Yes?
So you're sort of denormalizing the data?
No, it's actually, think of it like you have a river with lots of small streams coming in, and then they are all funneling into one big stream. And then one observer at the end of the big stream doesn't know it's actually many different streams up front. It's just one big when he's looking at it. And here, I'll give you a concrete example so it makes it clearer. So in Couchbase, in addition to doing nickel queries, so SQL-ish queries, you can also do views which are MapReduce and so forth. But that's not important here. But for our purposes, we are doing our view query, and we have beers stored in the database, and we ask for them by name, and we basically grab the first 100 of those beer results. And then, because the full SDK is asynchronous, so are our responses. And imagine you are doing a request against the server, and it's returning you in JSON chunks all those rows, basically, row by row. So what we do here is we call flat map, and we take the result, and then our rows inside our result are again an observable of type row, right? Because once you have a result which is like a 200 OK from the server, then all those rows will be streamed, which again is an asynchronous pattern, right? So you get those as they come along. So we use flat map to map from a result into our rows, right? And at this point here, the downstream consumer doesn't care about the result. It only cares about the rows that get streamed, right? So it's not an observable of observable rows. We just care about the rows down here. So every row will be emitted. And then to take it one step further, and I'll come back to this example a few times because it has some advanced stuff in here too. We call flat map again because it turns out we don't care about the rows. The rows only contain a document ID. And we want to get the full document. We want to perform a key value fetch for the document ID that gets returned by the row to give us the full document body. So we call flat map again on our row with document, and what document does is it does a KV fetch in the background. So here we are doing an asynchronous IO operation, and then we stream those rows, and then for every row that gets streamed, we are performing a key value operation against the database, right? So we have 101 network operations in the background, which is abstracted by this API, right? We don't need to send this off to a thread pool and wait what happens and so forth. This basically is happening in an asynchronous sequence. And then here comes our filter into place with a specific use case. So we say, okay, all our documents arrive, but we're only interested in the beers that have an alcohol by volume over 5. So we use filter to filter them and drop all them on the floor that have less than 5% alcohol by volume. And then we use count, another operator by Rx, which just counts the elements in here. And then once the onComplete event is sent to count, it will send the counted value to our subscriber. So this will probably print something like 50 or 52. It doesn't matter how, basically how much exactly, right? So, but this is in 6 lines of code. You are basically doing over 101 network operations, right? And you do them as fast as possible because, let me quickly check the time. Okay, that's fine. So what also happens here, which is not obvious, is that we are streaming all those documents, and this is a KV call, right? So we are grabbing the full document. But imagine you have a 50-node cluster, and then it sends out all those requests in parallel. So it's actually doing those 100 KV fetches in parallel, and it's not like doing one, waiting for it, and returning it, but it's actually sending them out in parallel. And as they arrive, it's sending them into filter, right? So it's really like you're doing 100 calls in parallel, which is, again, transparent to you. And then as they come back, we filter them, and once all of them came back, we get an uncompleted event. We don't, yes? Well, sending it to the server in this case would mean that you would, let's say, you write a nickel query where you already provide your predicate and so forth. So in this example here, there is no coordination between the client and the server. This is really just like client-side filtering that's applied. Another interesting thing is buffer. With buffer, you can transform your observables as they come in an uncoordinated fashion. You can buffer them based on a specific like time frame or count. Here we say, as they come in, we buffer them in batches of 3. Why would it be useful? Here's another example. So imagine we call observable.interval. So every 100 milliseconds, we get an event into observable stream. And then we buffer them up. So this is just faking, right? So imagine instead of sending something every 100 milliseconds, we get events from an event stream, right? In some kind of fashion. But here's the important part. We call buffer, and it buffers up all the events that are coming in for a 5-second period. And then once that 5-second period is over, it sends all of them in one shot. So then we're using flat map, and then we map. So these are the IDs, right? 1, 2, 3, and so forth. That it's counting up every 100 milliseconds. And then we create an observable from those IDs, and then we map them into some kind of ID structure. Here we just say ID : 1, and that's our key on the document database, right? ID 1, 2, 3, 4. I'm just making something up. If they would probably come from your data source, right? A Twitter feed or whatever. And then we call flat map again, and on our bucket we call get with those IDs, right? So imagine you don't have the buffer in here. We would just send get requests against the server as they arrive, right? And there is very little coordination. But if we know we can trade some latency for increased throughput, we can batch the data up and send them to the server in one batch and then get the result back. And here you can see this is all asynchronous, but you can turn an observable into a blocking observer, which technically turns it into an iterable, right? So you can do an asynchronous sequence, and then at the very end, you basically create an iterable and then consume it in a very old-fashioned way. It's not the best way to work with. Ideally, you would have asynchronous all through the stack, but very often you build some kind of layer that's asynchronous, and at some point you need to expose a blocking API to your upstream system that just expects a synchronous response. But you still benefit from the parallel fetch and everything until the response is done. And this is how it would look like on the server, right? So every 5 seconds, it would batch those 50 requests up into one shot, and we would do 50 gets, and then it would wait, right? So this is how it would then look on the server, right? So you're batching those incoming requests up into 5-second intervals, and then you fetch them in a batch. All right. So I guess now you're all experts with RxJava. Let's move on to the serious stuff, right? Questions so far on RxJava basics? I know it's a lot if you haven't used it before, and I have to tell you it doesn't get better from here. So with Couchbase Nickel, and I'm going over this just very quickly because we need the API. So you can execute queries very much like SQL. So there is a simple string where just pass in a Nickel query, you get a response. You can also do parameterized queries, and you can also use prepared statements in a way with the API. So how does a result look like? So here we have our asynchronous Nickel result. And today we are only interested in the rows, but here you can see there is much more information available. You get errors on the response, signature, final success. And why are some of those observables and some don't? Well, we get the response from the server. These 3 come at the very top. We basically can take them right away. But then the server streams all the rows, and this is it could be thousands of rows, right? So we make every subsequent component also an observable because we never know when they complete. So you can consume them in an asynchronous fashion even if they come in a few seconds ahead. That's the beauty of those asynchronous APIs. Simple example, simple query. You can say select name from, and this is our database, our bucket as we call it, where so our travel sample has airlines and airports and those kind of data. So we say select all the names from the travel sample where the type equals airline, limit by 3. So again, we do our query. We have our flat map. You probably recognize that pattern already. We extract our rows from our result and then we print them. And it will say, okay, we have 3 airlines, 40-mile air, and so forth, right? So this is how you execute a Nickel query in a completely asynchronous sequence. Pretty simple actually, right? You can use named params. So you do, and what we also provide, if you're familiar with Juke, we have something similar where we provide some kind of builder API to let you write those Nickel statements and avoid basically mistyping stuff. So you can say select name from current bucket where, and then we create an expression where type equals $type, and we also can add a limit. And then because we have named params, we add our params and say type is airline. And then here we pass in our params in addition to the query, and we can do parameterized queries right away. We also have positional params, looks very similar, but instead of saying $type, we say $1. And then instead of passing in a JSON object, which is a mapping, we just pass in a JSON array of type airline, right? So very similar to what you're used to from a relational database in this regard. Now, a little more advanced stuff, and I just put it up here so you get a feeling how you can use Rx in more advanced patterns. So here we are creating a primary index on our database. Our query says, create primary index on travel sample, and then do on next. Every method that is prefixed with do is an explicit side effect. So all those operations that you've seen before, map and filter, they alter the stream. Side effects, like do on next, do on complete, do on error, you can do stuff, but it's not altering the sequence. This is very important because you want to make it explicit where you're side effecting things in a functional programming context, or you are changing the sequence. So here we say, every time something is emitted here, a result, we subscribe to the errors and print it out, right? You would probably log to warn here and so forth if something goes wrong. And then what this will return us is some kind of information, and then we block it and print out the information, right? But this is the important, but here we create a primary index, and then as a side effect, we print if anything goes wrong while creating the primary index. So what can we do after we created it? Maybe we want to select the different indexes that are in the database, right? Here's our query. We say select indexes from this specific collection, which has all the indexes on the server, where key space ID, and this is our bucket name, is travel sample. So what this query will do is it will return us all indexes for this specific bucket. Again, we do query, then flat map, and then because we only care about the value of our rows, we call map. So we extract from every row, we extract just the value, and then we use map again from the value to just extract the name. So what this will do, it will query the server asynchronously, it will grab every row that it gets back, and then it just extracts the name. So what this will do, it will print all the names of the indexes for a specific bucket. Now let's crank it up a little bit. Conditional index creation. What if we want, in a completely asynchronous sequence, we want to check if an index exists, and if it doesn't exist, we'll create it, right? So we have two queries here, I put them on the top. So the first nickel query, again, is the first one before, where we select the indexes for a specific bucket. And then another query says create index with an index name on our bucket where the type equals airline. So this is our index that we want to create. Now, oh, okay. Can everyone see to the bottom here? That's probably... Okay, I'll just explain it, right? So we perform a query. This is our select from before. And then we filter on the name, because we want to make sure if this specific index is in the sequence, then we let it pass through. If not, we'll get an empty sequence. And then there is an operator down here which says switch if empty. And what this allows us is to switch to another observable sequence if the current observable is empty, right? So we say switch if empty to this query. So if our observable sequence where we select the indexes is empty, then we switch over to the other one and asynchronously create the index. And then at some point it will return once the index is created. So you can see how you can compose, and basically like in a train system, you can go on another track if some expression matches and so forth, right? Another one, transparent query caching. Imagine our nickel query is very expensive. And because Couchbase can also work as a key value cache, you want to probably store the result with a time to live, and then only if the document is not there, we'll go to the cache. Okay, to the query. Let's do that. So the first thing we do is our query down here says bucket async get. So we do a plain key value get for our my result cache, right? That is our cache document inside the database. And then we call map to just extract the content. And then again, switch if empty, because the observable will be empty if the document is not on the server side. Switch if empty, go to this thing here. And what does this thing do? Again, we do a nickel query with our select query, right? Doesn't matter what it is. We extract the data. And then as a side effect, do on next, we store the document in the database with a time to live of 10 seconds, right? So this will, for the next query that comes along and it does the get, it will fetch it from the cache, and then we could basically take it from there. And if no one, or if the cache expires for 10 seconds, then it will go to the switch if empty sequence and do this thing. And this is the important part, right? Imagine you start out with the query and your API exposes an observable of type JSON object. That's fine. And at some point down the road, you think, maybe I want to introduce a cache for optimization. Well, this code also still exposes observable JSON object. So your upstream component has no idea what you're actually doing underneath, but you can do that in a completely asynchronous fashion without breaking the contract, right? So you can evolve the underlying implementation without breaking the contract. All right, to finish this up a little bit, let's talk about error handling. Error handling is a very important part, so I love to talk about error handling. I used to do talks just on that topic alone. So if you are interested in more about this, we can definitely talk over lunch and later on. So the key part to realize first is you need to prepare to fail, because things will go wrong, right? We all know that, and you don't want to wake up at 3 a.m. by your pager. You actually want to plan for that up front. That's much better, right? It's easier said than done, though, because very often error handling is an afterthought, right? You implement the application, your tests pass, and then someone comes along and says, hey, actually, what happens if this thing fails? And the classical example is most people think about error when like they talk to a server component, well, it just doesn't return anything. But who has let me ask you a question. Most of you have probably talked to a web server or HTTP, but who has actually expected like JSON or anything, but got back an HTML 500 with HTML tags in between? Someone? Yeah, quite a few, exactly. So it's not only about getting no response, but it's also actually getting a response you didn't expect, right? So that's also something you need to keep in mind. And if your API expects some kind of format, it's very hard to basically work around that if you didn't plan for that upfront. And at least in my experience, synchronous retry and fallbacks are really hard to get right. Because if you have one API call, which you have a synchronous timeout, like it takes probably 2 seconds, that's fine, right? So you can maybe do a retry loop, but things start to get really, really hard when, let's say you do 50 requests in parallel, and then you need to think about, okay, what if this one takes, my total time budget is 5 seconds. How do I split it up? Do I divide it by 50, right? Or how do I handle retries that I'm still in the budget? Then you add thread pools, and then you do all kinds of measurements and so forth. With a completely asynchronous context, all those things click into place directly without having you to think about all those nitty-gritty details. And the cool thing is RxJava provides almost everything you need. You get fallback handling, you get retry handling, and you get fail fast, which are the 3, I would say, main building blocks of building resilient systems. The other thing is timeouts. So every operation inside the Couchbase SDK enforces a timeout. I'm a heavy proponent of timeouts. I think everything should have a timeout, because that's your last line of defense. And we had one forum post on the Couchbase forum. So we introduced a new API, and we were happy we put timeouts everywhere. And we have 2 overloads. One uses a default timeout, and the other one allows you to specify custom timeout. And we had this guy asking on the forums, like, why is my application not responding for, I don't know, many minutes? I was like, wait a minute, we have this timeout on there. And then he was basically setting the timer to integer max int. And it was like, okay, that's probably working around very hard around the timeout thing, right? So always set realistic timeouts. That's really your last line of defense. Because also the SDK contains bugs, right? If we have a bug in the SDK which doesn't return you anything, your timeout still allows you to bail out and do something else, right? You're not getting stuck. So how would that work with RxJava? It turns out 2 minutes? Okay, then very quick. So you can use the timeout operator here to basically go specify timeout, and if nothing gets emitted into the sequence for your timeout, then you will get a timeout exception, which you can then handle and do something else with it. This is how it looks like in the blocking API in Couchbase, right? All we do is we take the asynchronous API, we call the timeout that you set to blocking, and then return it, right? That's all there is to it to go from an asynchronous API to a synchronous one. Totally easy. And then a little more complex examples here on our query, and this is the one we've seen before. As I said, we are doing 1 request here and then 100 requests down here. Now, what can we do there? Well, we can introduce timeouts on many places. We can say this query is allowed to take only 500 milliseconds, but the whole sequence is only allowed to take 2 seconds, right? Or you can even put the timeout on the individual operations where you fetch the documents. So you can be very granular, but you still have one logical flow. And doing this in a synchronous context is insane, right? Doing the same thing. Failing fast, retrying, and as part of that, what RxJava allows you to do is actually it gives you more operators, which I didn't get time to go into here. But for example, there's on error resume next, where you can say, if this observable fails, go to another observable, right? So you can chain observable sequences together based on errors that happen, right? And then you can use side effects where you can say do on error. You can add timeouts in all kinds of places. You can use on error return to return a specific hard-coded value if everything else failed, right? And then the last thing I wanted to mention is that it also has very sophisticated retry handling. Asynchronous retry is also very hard. But the Java SDK, we provide a retry builder where you can say, retry this observable when any of this exception happens with an exponential delay up to 5 seconds and a maximum of 100 times. It will do the retry asynchronously in the background, and only if this condition doesn't hold anymore, it will propagate the error, right? In the completely asynchronous sequence. So I think with that we are 1 minute over, but I'm happy to take any questions at lunch, and I'm here the full 2 days. So thanks very much for taking the time and staying with me for that very intense topic, I would say. Thank you.